In this video, we're going over combination sum 3. So find all valid combinations of k numbers that sum up to n such that the following conditions are true. Only numbers 1 to 9 are used, and each number is used at most once. So I want to return a list of all possible valid combinations, and the list must not contain the same combination twice, and the combinations may be returned in any order. So in our first example, we're given k is equal to 3 and n is equal to 7. And then we have the one valid combinations where the sum of the elements is equal to 7 and there are 3 elements inside the combination. Let's go over the thought process. So we will be implementing a recursive backtracking approach. For each of the elements x, where x is greater than or equal to 1 and less than or equal to 9, we can include x in our current combination if x is less than or equal to n. This is because the elements inside our combination has to be equal to n. We do not want to go past it. After including x in our combination, we can continue to find the rest of the combination for n minus x. We should note that we are not allowed to use the same element twice. This means after including x, we should continue to search for elements from x plus 1. This will prevent us from including duplicate elements. Now, after finding the current combination, we will backtrack our steps by removing the last elements from the current combination. This will give space for the next elements to find the next combinations. Now let's go over the pseudocode. So we're going to create a list, results, to keep track of all combinations. Then we're going to implement a recursive backtracking approach. Now, what parameters do we need? We'll need I, our current starting elements, and com, which will be our current combination, and results will be list of all combinations, and also k, the input value, and also n, the input sum, or the current sum. Now, what's the base case? If k is equal to combination.size, this means we have found a combination of size k. We want to check if sum, our current sum, is equal to 0 or not. So if n is equal to 0, we have found a valid combination. We're going to add a copy of combination to results. Then we can return from the recursive call. Then each of the recursive call, we're going to iterate through from I to 9, denoted as j. Now, if j is greater than n, this is an invalid value. We can just break from the loop. This is because all of the elements after j is going to be greater than n anyways, so there's no point of keep checking forward. Now I'm going to add j to our current combination. Then we're going to recursively find the rest of the combination. We need to update the sum to m minus j because we have included j in our current combination, so we want to decrement it from our current sum. And also, we need to move our starting index forward to j plus 1. This is because we do not want to have duplicate elements in our combination, so we need to continue to search forward. Now, then we're going to remove the last elements from com. This will allow us to backtrack our steps. Then after we have finished our recursive calls, then we can return results. Now let's go over the code. So we're going to create a list of list results to keep track of all combinations. Then we're going to implement our recursive backtracking approach to find all combinations. Our initial starting index I will be 1 because we're only allowed to have elements from 1 to 9. Then we have our list for our current combination. And then we have our list of all combinations and our input values. Then we can return the results. Then we're going to create our recursive backtracking method, our starting index, our current combination, list of all combinations, and input value k and n. Now what's the base case? If k is equal to 0, this means, no, if k is equal to combination.size, this means we have found a combination of size k. We want to check if n is equal to 0 or not. If n is equal to 0, we have found a valid combination. We're going to add it to our resulting list. Then we can return from the recursive call. Now we're going to iterate through from I to 9, denoted as j. If j is greater than n, we should not be searching forward anymore. We can just break from the loop. Now we're going to add j to our current combination. Then we're going to recursively find the rest of the combination, starting from j plus 1 to prevent duplicates, and also decrement the sum by j. Now we want to backtrack our steps. After we have found one combination, we want to backtrack our steps. This can be done by removing the last element from our current combination. Let me know if any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.